So I gave you the high-level definition of Bitcoin and Ethereum, but now let me describe the details of why they're unique and different, and then what blockchain proofs are. So I've mentioned the term miners. We've talked about how they work with nodes and validators, but let's talk about the proof, the mathematical proof, or the work that happens behind the scenes, so you have an understanding of how these chains or different blockchain networks are unique. Proof of work is when miners have voting power proportional to the amount of computational power of the network. And proof of stake is when validators are stakeholders with voting power proportional to the economic stake locked up. Now let me break down what this means and why it's different. First, what is consensus again? Consensus is when we confirm the validity of information written in these blocks. So everybody's agreeing to what's happening across the board. Why is this important? Because we have to solve for a problem, and everybody has to solve for a problem together at the same time. So what is the proof of work problem? Think of mining as a massive competition. You're all playing, let's say, Hungry Hippos. It's random in process. The faster you chomp, the more likely it is to win. So calculating hashes, as we mentioned, the computational function that you need to solve for, increases the chance of winning. If you do it faster, you'll get paid more for the speed and accuracy. So proof of work is the algorithm used by Bitcoin. It has slow throughput. It's expensive to mine. One unique characteristic to Bitcoin is that it has only 21 million Bitcoins in supply. So reward subsidies will end, and miners will eventually have to receive only subsidies. That's in reference to the rewards they get for doing additional work, either based on speed and accuracy. And at the current point, about 18 million Bitcoins have been mined. There are about 2.5, 3 million plus that are left in the system. So at a certain point in time, these subsidies will go down in value. So the proof of work problem is costly and time consuming to solve, but it's easy to mine, easy to verify. The goal is to find the hash of a valid block header with a value less than the target value. So how do we use the proof of work? One aspect is the proof of work requires CapEx. I mentioned that you need hardware and some software to actually do this. So the hardware is ASICs or other computer equipment. ASICs as a computer, as a type of computer, and you'll obviously need access to either some office space and some power or electricity to access the network. So you have some costs when it comes to proof of work. You need to put in so much money, so let's say like $10,000-$15,000. And on the right, you can see why you can't cheat Bitcoin. It refers to how computations are performed over a period of time. These are realized costs, whether you're a successful miner or not, whether you make money or lose money. You're putting up real money to buy the computer equipment, pay for electricity, pay for the office space and other equipment to access the network, to do the work required to validate transactions. So how does proof of work validate peers? So instead of silo decisions, proof of work has proposers and voters. As we mentioned, there are thousands, hundreds of thousands of these nodes and validators online. And proposers submit a transaction to everyone else. The peers cast a vote. And then transactions are only saved after receiving a certain number of votes. And this is something that has been decided upon in the network and the developers on chain. What are the drawbacks of the system? There's no defender advantage, meaning the cost of attacking and the cost of defending are one for one. And we mentioned before, when defining what proof of work is, it really comes down to the computational, can you buy computational power? So can you buy enough computers? What's your access to electricity? We talked about mining pools. The reason you would create a mining pool is to achieve scale. Instead of having one computer, there would be more scale, economies of scale if you have 2,000 computers. So the constraints are inflexible. Computation, electricity, there's nothing in place to prevent, discourage malicious actors. And proof of work simply allows it. The only way to discourage it is to increase the incentives for honest behaviors.